Okay, so this next example, we're just gonna take our time and work through this. It's very complicated, and we're just gonna take one step at a time. But first of all, sketch the graph. They give us an x equals equation, which means, first of all, we got to be able to graph this. X equals 5 and about x equals 5. So if we take a few minutes, we want to also note that if it's revolving about x equals 5, parallel to that will be a dx vertical rectangle. So you're going to have to solve everything for y equals to start. Okay, and we're going to do that in just a minute. So what I have here, and we're going to do some scratch work with that y equals, is I've sketched the graph of this thing and labeled everything that I know. Now, this stuff is, and this should be y equals, and y equals. Don't worry about that just yet. I'm going to show you how we got all those values. So what we're going to do is the first thing is we need to solve the equation for y equals, because the axis is parallel. Our representative rectangle will be parallel to this. So first of all, my first thought is that I'm going to have a dx. Okay, that's my first thought. The next thing, I'm going to have to work with my radius, but before I even do that, I want to solve everything for y equal. Okay, we're just going to have a scratch work page for this. So the first thing we want to do is solve for y equals. So if we have y squared over here minus 6y is equal to negative x. So firstly, all I did was bring all my y values over here and x values over here so that I'm going to set up completing the square method to do this. Now I know it may be a while, so I'm going to say complete the square method. Like I said, this one's painful. Okay, using complete the square method, we're going to have, we have y squared minus 6y. We're looking for this value so that it makes the left side a perfect square. Whatever you do to the left side, you will have to do to the right side as well. So let me remind you to complete the square method. To find the box value that we're looking for, you take the b term, divide by 2, and square it. Okay, what is our b term? Remember, in labelling quadratics, your a is 1, your b is negative 6, the c is the value we're looking for. So what is our b term? Negative 6 divide by 2, and then square it. So what's negative 6 divided by 2? Negative 3. And then what's negative 3 squared? 9. So that allowed us to find 9. Well, if I add 9 to the left side to balance it, I add 9 to the right side as well. Now, what does this factor to? What multiplies to give us 9 but adds to give us negative 6? Y minus 3, y minus 3, which I can just say y minus 3 squared. And then over here, I'm just going to write it as 9 minus x. Okay, I'm trying to solve for y. Let's keep in mind what we're doing. How would I get y by itself? What's the first thing I need to do? Very good. Take the square root of both sides. Take the square root. A square root undoes a square, so we get y minus 3 is equal to plus or minus the square root of 9 minus x. Still need to get y by itself, so what do? Add 3 to both sides, so we get 3 plus or minus the square root of 9 minus x. I know. So this part of the graph from here to here is y equals 3 plus 9, 3 plus the square root of 9 minus x. And from here to here is 3 minus the square root of 9 minus x. So that's where that value came from. Okay, let's work on our radius. I told you if from here to here, because our axis of symmetry is that x equals 5, is 5 units, and from here to our representative rectangle is x, then what would be our radius from here to here? X minus 5. Good, so this would be x minus 5. Okay. Now the height, what do you think about the height of this representative rectangle, don't you agree with me that it'll be the value here minus the value here? So that's going to be, let's take our time to do this. So it'd be 3 plus, actually square root of 9 minus x. Subtract out the bottom portion of that rectangle, which is represented by 3 minus the square root of 9 minus x. Actually, we're going to go to the next page and do some scratch work on that. Okay, so we're coming over here on our scratch paper to simplify this. So I distribute this negative out first of all, and that would just give us minus 3 plus the square root of 9 minus x. So what about this 3 and this negative 3? Gone, right? Now these two terms are the exact same terms. So if I have one term of this plus a known one out front, how many do I have when I add them together? 2 of those. Good. No, so those are going to be the same terms. So if you will, I'm going to come back over here and put the simplified version of this, which is just 2 square root of 9 minus x. Okay, and next thing we're going to do is plug it into our volume. So it's the interval from, what is our values? 5 to 9, right? From 5 to 9, make sure you keep in mind just the highlighted portion of it. So from x value of 5 to the x value of 9. And our radius is x minus 5. Our altitude is simplifies to 2 square root of 9 minus x, and our thickness is dx. So we're also going to go to another page and do some scratch work with this. And my 2 pi. Almost forgot that. Let me add that in. 2 pi. Okay. This problem is just gross. It just doesn't get much better. So we're going to just take our time, work through this. This one we're going to have to use substitution here. So the first thing I want to do, let's just see if we can do some simplifying first. So what if I take this 2 and multiply it by this 2? Okay, we'll get a 4 pi out front. Then we'll have x minus 5. And then here, we get this. Now, next thing we're going to do is use substitution. So we're going to come off to the side. And we're going to say, let's let our u be 9 minus x. Right? Because this can be rewritten to the 1/2 power. So let's let our u be 9 minus x. So what would du be? What's the derivative of this? Just negative 1 or just negative dx, right? Okay, good. Now, if I'm going to change to use substitution, what about these intervals? They're in terms of x, and we need them to be in terms of u if I'm going to use u. So we're going to do some scratch work over here, and we're going to say when x is equal to 9, u is equal to, well, let's put a 9 right there. What's 9 minus 9? 0. Good. So when x is 9, u is 0. All right, now let's do the same thing when x is 5, u is going to be what? So if put a 5 here, what's 9 minus 5? 4. So now we have a 4 here. Now, we're going to, let's see, I don't know that necessarily the best way to go about this, but if I said square root of u, that's this, square root of u, okay? Then I'll have my du, which is a negative dx. Well, what's missing? That negative, so what do? We're going to pull this negative in front to account for that negative dx over there, okay? Now, I'm going to write this, and you're going to have to see it, and then I'll explain why we do this. So 9 minus u minus 5 du. Now that came from, if I solve this, we can solve anything for any variable we want. What if I ask you to solve this for x? I want to get x by itself, so I would write subtract 9, subtract 9, so I would get x is going to be 9 minus u, right? I could just move that over. X equals 9 minus u. Or let's just pull that variable out. So that would be u minus 9 is equal to negative x. Divide both sides by a negative 1. And that would just give us x is equal to 9 minus u. Okay, now x is equal to 9 minus u. Right? Now I need these all be all in the same variable. If I'm going to write this with a u, I need this to be represented with a u. So basically what I'm doing is changing the variables. So this x I rewrite as the 9 minus u, which we saw for over here. And then it's still minus 5, and then I have my du. Okay, so that's something we haven't really done a whole lot before, so I'm just going to rewrite so that all of my variables are in the same term, so u. Okay, now let's just simplify that. Actually, we're also going to do something else. What about these two? This one's 0 and this one's 4. What can I do with these if I want to switch them? Yeah, I pull a negative out. What will that make this become? A positive, right? So then that would be positive 4 pi, and I'm going to put this in red so we can see that we switched it. So from 0 to 4, I'm going to make a note. I'll say switch, which is going to affect that. This I will rewrite as u to the 1/2 power. And what would this side simplify to? 4 minus u du. Okay, so we just do 9 minus 5 is just 4 minus u. Now let's algebraically simplify. Distribute, distribute. I know, hang in there. I told you it was not very pretty. So that's just going to be 4u to the 1/2 power times. Now this is u to the first power. What's u to the first power? When you multiply like bases, add the exponent. So what's 1 plus 1/2? U to the 3/2 du. We are finally ready to integrate and evaluate this thing. Finally. Okay, so we say 4 pi. Actually, let me go ahead and, so to the plus 1 would give us what? 3 over 2. And then that, if we were to do that, just so you see, it would be 2 over 3, which that simplifies to 8 over 3. Good. 8 over 3, I'm going to move this out the way. Okay, so that's 8 over 3. Then minus u to the 3 over 2 plus 1 would be u to the 5/2 from 0 to 4. Now the only nice thing about this is we have a 0 in there, so we like that. We're happy to have that 0. Okay. Okay, and so we work our way through the rest of this. You can pause it and check your work, and we finally get to 107.23 units cubed. And that problem is about as painful as it gets. Fortunately, if we would be willing to do the disk method, it's as simple as this. So first of all, disk method means whatever your axis of symmetry, we draw perpendicular. So our representative rectangle is dy. We solve everything for to be in terms of y equals, and then we just have pi times our radius squared dy. So we would just be able to plug it in here, and our intervals in terms of y, and it's just that simple. So, yeah, so your question is, when do we have to use shell? When do we have to use dishwasher? Sometimes it's going to be easier to use one method versus the other. And I think about, if you more than less than halfway through this particular problem, you would have probably stopped and just tried one of the other methods.